SpaceX may go public, but its value was built long before any stock ticker. The company became the world's most valuable private company by changing the cost of reaching space. Its biggest advantage is not one rocket. It is a connected system of reusable launch vehicles, mass production, satellite services, and ambitious long-term goals. To see why investors value SpaceX so highly, start with the old space business. For decades, rockets worked like disposable airplanes. A rocket launched once, carried a payload, and then burned up or fell into the ocean. Every mission required a newly built first stage. That made launch extremely expensive. Governments could afford occasional missions, most businesses could not. SpaceX attacked this cost problem with one simple question. Why throw away the most expensive part of the rocket? The first stage contains large engines, fuel tanks, computers, and plumbing. It also does most of the hard work. It pushes the rocket through the thick lower atmosphere, then it separates from the upper stage. Instead of disappearing, a SpaceX booster turns around. Small thrusters guide its direction in space. Grid fins steer it during the fall back through the atmosphere. The engines restart and slow the booster down. Landing legs unfold near the ground. The booster lands vertically on a pad or drone ship. That landing looks dramatic, but the business purpose is simple. A recovered booster can fly again. Reusing hardware spreads its original manufacturing cost across many launches. Think of a taxi instead of a single-use rental car. The more paying trips it makes, the lower the cost per trip becomes. Reuse is difficult because rockets face brutal conditions. Engines vibrate, heat up, and burn fuel at enormous pressure. The vehicle also returns through hot, fast air. SpaceX had to learn which parts could fly again safely. It also had to make inspections quick and affordable. A rocket is not truly reusable if refurbishment takes years. The Falcon 9 became the proof that frequent reuse could work. Its first stage has flown many times. Its payload fairings can also be recovered and reused. Those two nose cone halves protect satellites during launch. Even partial reuse lowers the cost of each mission. Lower prices attract more customers. More customers create more launches. More launches create more practice, data, and revenue. This forms a powerful loop. Lower cost leads to higher flight rate. Higher flight rate improves reliability and learning. Better reliability brings larger contracts. Larger contracts fund more rockets and factories. SpaceX also built its rockets with a different manufacturing mindset. Traditional aerospace programs often depend on long chains of specialized suppliers. Each supplier adds time, cost, and coordination problems. SpaceX produces many critical parts inside its own operations. It designs engines, software, structures, and electronics closely together. This vertical integration gives engineers faster feedback. A design problem can move from the launch site to the factory quickly. A factory change can return to the launch pad quickly. That speed matters because rocket development requires constant testing. SpaceX treats tests as sources of information. A static fire test checks engines while the rocket stays on the ground. A launch test checks the complete system under real conditions. When something fails, engineers study the hardware and data. Then they change the design and test again. This process can look risky from the outside. But rapid testing can reveal problems sooner than long paper reviews. The company's main workhorse is the Falcon 9. It carries satellites, cargo, astronauts, and SpaceX's own Starlink satellites. Using one rocket family for many jobs increases production volume. Higher volume helps standardize parts and procedures. Standardization reduces mistakes and lowers unit costs. Falcon Heavy adds more lifting power by connecting 3 Falcon-based boosters. This lets SpaceX carry heavier payloads without creating a completely separate system. The Dragon spacecraft adds another valuable capability. Cargo Dragon carries supplies to the International Space Station. Crew Dragon carries astronauts there as well. These flights made SpaceX a major partner for NASA. Government contracts provided revenue and technical credibility. They also proved that a private company could safely transport people to orbit. Yet launch services alone do not explain SpaceX's enormous valuation. The second major engine is Starlink. Starlink is a network of thousands of small satellites in low Earth orbit. These satellites send internet signals to user terminals on the ground. A user terminal is a compact dish that points toward the sky. Instead of relying on one distant satellite, the dish connects with nearby satellites passing overhead. Low Earth orbit is important because the satellites are much closer to users. A shorter distance can reduce signal delay. Lower delay makes video calls, gaming, and business tools work better. Starlink targets places where cables, fiber, and cell towers are weak or absent. That includes rural homes, ships, airplanes, disaster zones, and remote work sites. The addressable market is far larger than the launch market. A rocket launch is an occasional purchase. An internet subscription can produce monthly revenue for years. That difference changes how investors view SpaceX. Launches create access to orbit. Starlink turns that access into a recurring communications business. SpaceX launches many Starlink satellites on its own Falcon 9 rockets. This gives the company a major advantage. It does not need to buy every launch from another provider. Reusable rockets lower the cost of building the constellation. The constellation then creates customers and cash flow. That cash flow can help pay for future rockets. Another loop appears. Cheaper launches grow Starlink faster. More Starlink users create more revenue. More revenue supports more satellites and launches. More satellites improve coverage and network capacity. Better service attracts more users. Operating a huge satellite network is not easy. Satellites must avoid collisions with other spacecraft and debris. They must move into the correct orbit after launch. They must communicate with ground stations and user terminals. They also need to leave orbit safely at the end of their lives. SpaceX uses onboard propulsion to raise, adjust, and lower many Starlink satellites. The company also develops laser links between satellites. These links can move data through space without sending every signal down immediately. That can help connect distant places across oceans and continents. The third technology pillar is Starship. Starship is a much larger rocket system designed for full reuse. It includes a giant booster called Super Heavy. Above it sits the Starship spacecraft. Together, they are meant to carry large amounts of cargo and eventually people. The system uses methane and liquid oxygen as propellants. Methane can be produced in several ways on Earth. It may also be possible to make methane on Mars using local materials. That idea supports SpaceX's long-term Mars plans. But Starship's immediate business value is simpler. A fully reusable heavy-lift vehicle could reduce the cost per ton sent to orbit. It could launch larger batches of Starlink satellites. It could carry satellites too large for current rockets. It could support space stations, lunar missions, and in-space manufacturing. Starship is still under development. Its test flights have included spectacular failures and important successes. Each flight provides data about engines, heat shields, fuel transfer, and re-entry. SpaceX is betting that fast learning will eventually create a far cheaper launch system. Investors do not value only today's revenue. They also value possible future markets. Starship represents an option on those future markets. The company's value also comes from scarcity. Very few organizations can design orbital rockets, launch them often, recover them, and operate a global satellite network. Even fewer can carry astronauts for NASA. These capabilities require factories, launch sites, licenses, software, skilled teams, and years of flight data. That collection is hard for competitors to copy.
SpaceX benefits from scale as well. A busy launch schedule keeps teams experienced. It keeps factories active. It creates a steady stream of performance data. It also gives customers confidence that their satellites can reach orbit on schedule.
However, a high valuation is not a guarantee. Rocket failures can ground fleets. Satellite networks require huge capital spending. Governments can change regulations for spectrum, safety, and competition. Rivals are building reusable rockets and satellite constellations too. SpaceX must keep launching, improving, and serving customers. Its core lesson is not simply that rockets can land. The larger lesson is that technology becomes more valuable when it creates reinforcing loops. Reusable rockets lower launch costs. Lower costs increase launch frequency. Frequent launches build Starlink. Starlink creates recurring revenue. That revenue funds bigger technology bets like Starship. Starship could lower costs again and open new markets. This is why SpaceX became more than a rocket company. It built a transportation system to orbit. Then it used that system to build a communications network. Now it is building a larger system that could expand both businesses. If SpaceX goes public, investors will not be buying a single machine. They will be judging this entire flywheel. The key question will be whether SpaceX can keep turning cheaper launches into larger, repeatable businesses in space.